Hello Lakesy students. Today we're going to look at how to graph a quadratic equation. So basically we're embarking on a new adventure in math. Your learning objective for this particular video: I can graph a quadratic equation that is in standard form. So standard form, what does this mean? Standard form is when it looks like y equals ax squared plus bx plus c. So basically the x squared terms first, x is next, then the no x is last. These equations will graph into a U shape, which we're going to call, or what is called, a parabola. Now, there's multiple parts of a parabola. Just like our v-graphs and the absolute value ones, that made the v's, right? Each parabola has two sides and a turnaround point. That point is called the vertex. So right now I have this thing right here. The vertex, guys, is this right here. It's where my turnaround point is. It's when it stops going down and starts going up. That is your vertex. Now, where we can draw a line down the vertex there, that is your axis of symmetry. That's where you can take that U and fold it and they'll run on top of each other. And your x-intercepts are where they cross over. We've looked at that before already when we looked at just describing graphs in general, but that's going to come all back into play when we look at parabolas today. So you're going to want to grab out that foldable we made, the standard form, vertex form, and intercept form. We're going to write into this standard form tab, so go ahead and flip that open. So it's just some stuff about standard form. Like we said, it's f of x equals ax squared plus bx plus c, so it looks something like that. Some things to know about. If the graph will open up, so it's going to be a U that's going up like a normal U, if your a is greater than 0. So basically it's a 1, a 2, a 3, a 1.5, something like that. Your graph's going to go open down if a is less than 0. So basically a fraction. Okay? Or negative, or not a fraction, a negative of some kind. So negative 1/2, negative 1, negative 2. So basically, is there a negative in front of the x squared? To find the vertex, you're going to find the x value by setting x equal to negative b over 2a. So you're going to set whatever b is, divided it by 2a, and that's going to give you your x value. To find the y value of your vertex, you're going to substitute the x value you get in back into the equation. Okay? Then we're actually going to make a table for standard form. So let's actually try a couple of problems here. So I have this equation right here, x squared minus 4x minus 5. It's in standard form. And what I'm going to want to do is answer multiple questions here. But the first thing, let's graph it. So you're going to want to find your vertex first, because that's going to help you build in your table. So I know my vertex is x equals negative b over 2a. So b looks like he's negative 4 and a is 1, kind of like you were doing for the quadratic formula. So if I plug in my values, that would be a negative 4 all over 2 times 1, which would be 4 over 2 or 2, right? Well, what you're going to do is you're going to put your vertex in the middle of the table, because that's the turnaround point, right? So you're going to put it in the middle of your graph so you get some points on the end so you can see the actual full graph. So my x value is 2. So now what I'm going to do is I'm going to put numbers around that 2. I'm going to go 1, 0, 3, and 4. That way everything's around it and I'm not confused at seeing what's going where. Now, I have this separate column here just so I can fill in my work so you can see how I'm getting my numbers. So I'm going to take my 2 and plug it in for my x. So I'm going to get 2 squared minus 4 times 2 minus 5. So I'll get 4 minus 8 minus 5. Which I'm thinking is a negative 9, right? Yeah, negative 9. So let's plug in a 0. So I'll get 0 squared minus 4 times 0 minus 5. 0 minus 0 minus 5, well, that's just negative 5, right? Let's plug in our 1. 1 squared minus 4 times 1 minus 5. 1 squared minus 4 is negative 3. Negative 3 minus 5, well, that's just negative 8. Let's continue. Let's fill in the rest of our table here. Plug in my 3 for my x value. 9 minus times 3 is 12. So 9 minus 12 is negative 3 minus 5, negative 8. Notice we got a match here. Let's see if we get a match at the end here. So go 4 squared minus 4 times 4 minus 5. So that's 16 minus 6. Oh, hold on. 16 minus 16. 0 minus 5, negative 5. Notice they match. Just like our V's when they made the same line both sides, that's going to happen too. That's why we have a parabola. They have an axis of symmetry, so they're going to be on both sides the same. Let's graph these ordered pairs. 0, negative 5. 1, negative 8. 2, negative 9. 3, negative 8. And 4, negative 5. And then we're going to connect our dots so we can make a nice V. There we go. Now, let's answer a few questions. Does it open up or down? Well, our A is positive, right? It's bigger than 0. So this is opening up. Notice it's a U that's going upwards, okay? On my vertex, right here, 2, negative 9. Now, my axis of symmetry. Where can I fold this parabola so it's on the same side? Well, it's going to be right here, right? So, what kind of equation of a line would that be? Well, it hits the x-axis at 2. So my axis of symmetry will be x equals 2. Is this a min or a max value? Well, it is a minimum value. And my minimum value, that is the y value, that is the lowest point on your graph. This is a local min. It's what you're seeing right now. So my minimum is at, I think I graphed one too many. Whoops. I wonder why I was kind of looking funky. There we go. Should be there. Not there. Graphed wrong. My minimum value is negative 9, right? So y equals negative 9. That's the lowest y value I'm covering. Domain and range. Coming back again, ladies and gentlemen. So domain, remember, that's the furthest left x value to the furthest right x value. This graph's going to keep opening up. So I know I'm going to keep going to negative infinity. And it's going to keep opening to the right as well. So I'm going to go to positive infinity. Range, lowest y to highest y. Well, the lowest y, I'm hitting at negative 9. I'm going to include that. And I'm going off to infinity and beyond. Increasing and decreasing. It's coming back again. So I have, remember, we got to think of our car here. Here's my car. So he's decreasing, right? And he starts over here all the way. So he's starting at negative infinity, decreasing. And he stops decreasing at the turnaround point, or the vertex, which is right here. But now you're not going to use your y value, you're going to use the x value. So from starting over here all the way to that turnaround point, you're going decreasing. So I'm stopping decreasing at 2. And then I start increasing there till forever. So I'm going to start increasing at 2 and go for forever. Let's try one more example here. So I have this equation here, negative x squared minus 2x plus 8. So very first thing, let's find our vertex. So to find my x value, I got to go negative b over 2a. So negative b is a negative 2, so a negative 2, all over 2 times negative 1. Or 2 over negative 2, which is negative 1. So I'm going to put that in the middle of my table here. Negative 1. So let's put some numbers around negative 1 so we get a nice full graph. So I'm going to go negative 2, -3, 0, and 1. So let's plug in our -3. So -3, that'll be 9. A -9 plus 6, -3, 5. Plug in a -2, I will get -4 here. Plus 4, it's gone, so I'll be left with just 8. -1, 1, -1, plus 2, 1, plus 8, 9. 0, I'll just get 8. Let's plug in 1 here. So we got 1 squared, 1, tack on the negative, it's still -1. -2 is -3, plus 8, 5. Let's go ahead and graph this. So I got -3, 5. Whoop. -2, 8. Whoop. -1, 9. Graphed it correctly this time. Woohoo! 0, 8. And 1, 5. Let's connect some dots here. Make sure I put some nice arrows on the end. There we go. So now it's opening downwards. I have a negative for my A right here, -1. My vertex right in the middle there, -1, 9. Axis of symmetry. So I can fold this guy right here, right? So that would be my x-axis of -1. So x equals -1 for my axis of symmetry. Looks like I have a maximum value because I have a hill. My max value is the y value, the highest y value, which is 9. So my maximum is 9. Domain, covering all the negative x's, right? Because it's going to keep going up and up and up. Covering all the positive x's. Negative infinity to positive infinity. What about my range? You're going to go from lowest y's to highest y's. So my lowest y's here, it looks like I'm getting them all, right? Because I'm going to keep going up and up, or I'm going to keep going down with my graph. So I'm going from negative infinity. But am I going to positive infinity? What's the highest y value I'm covering? Well, my max, right? At 9. There we go. What about my increasing and decreasing? Think of your car. So my car, it looks like he's starting at negative infinity, right? Because he just keeps on, he's going to keep going in the negative x's, right? So he's increasing from negative infinity to right here, right? Where I have my turnaround point. So until -1. And then he's decreasing all right here. So that'd be -1 to positive infinity. And that's the end of this video. See you later, Sabers.